So, hey guys, with another question, I'm here, and this is also a part of DP. And we'll be solving this problem, coin change problem, and we are given an integer array coins, and we have to use those coins and different way that we could, make up to an integer which is given amount. For example, we can use one coin infinite number of times, and we have to give the minimum number of coins by which we could create the combination that sum ups to 11. For example, in this case, it is 5 plus 5 plus 11, 5 plus 5 plus 1. So, I'll tell you a very basic concept. Wait for a while. Okay, uh, I guess everyone has gone through the subsequence problem. It is a problem of backtracking. And what we do here, like we use include, exclude thing here. Like for example, like I want to create a subsequence. I created use an array. I included one. Fine. Then I included two. I included two. Then I included five. Then I start excluding it. I exclude five. Sorry, I exclude two. Then I keep on. Then I get 1 comma 5 in such way. Fine. We just shift the index to one. And the way we write it code is like solve of I plus one comma arr comma target or something. Target minus arr of I. In this way, we just increment the index and the exclude one part we write it like I plus 1, comma IRR, comma target. We haven't used anything here. Okay. The same things will be same. I'll tell you a new concept that we have to repeat an element over here. Like 5 is being repeated. But if we increment the index, that means that we cannot include the 5 again. That this 5 will be not be included again. For like I'm at 1. Fine. I included this. Now I want to include it again. But in this condition, include condition, I have done I plus 1, which means the index will shift over here. Means I have moved to the very next part. Fine. So I cannot include 1 again. So what we do new here is that uh, that we'll just remove this part. What we'll do, we'll just remove this part. And that's it. That's the thing we have to do. Fine. So I guess this makes the concept clear that we have to, this is the, basic thing that we have to do. And this will be our pseudocode. I'll add one more thing. Fine. That will be only, okay, I'll be doing in the code only. I have write it just now, but wait, I'll try to, delete this whole code. Fine. I have taken three, I have included DP. I'll delete the DP as well. And from here also, fine. First condition that if amount is less than equal to 0 or I is greater than coins dot size minus 1, I have to enter this part if amount equal to 0. So return 0. I'll explain it why I'm doing it. Just keep your eyes on this code. Return int of max if the condition is not satisfied means amount is less than 0 and which shows that it goes out of hands. Fine. So I'll create an int include the same code that I write behind I comma coins comma amount minus of ARR of I. Okay, so learn the basic concept here. Like for example, in this thing, if 11 is the amount minus of 5, which will leave 6 again. Again, this function will be called. Again, this thing will go on. Fine. Okay, this amount minus of. Yeah, fine. And if in any case it returns int max, then I have to avoid this situation as well. And we have to increment this. So if include not equal to int of include okay, include first and in same way I'll create exclude and solve of this very same code I have written I plus 1 comma coins comma oh, Okay. And I have to return the minimum of votes because I want the minimum number of coins required. Fine. Uh, I think so. I've done something wrong. Yeah, here it is. But, this will work. This will work for sure. I think so. This must work. Compile error means syntax error is there. Um, undeclared DP. Oh, sorry. I have removed DP. I forgot to remove it from the main calling syntax. And that is slow. I don't know why. Okay, fine. This is accepted. And again, the DP problem, the time limit exceed will be always be there. Uh, okay, till it is submitting, I'll just explain the code how it works. Int of result solve 0. This is a recursive call. Fine. And I'm returning int max. Fine. I'm returning int max if minimum number of coins are not possible. Fine. So what I'll do if it is equal to int max, I'll return -1. Fine. But if it is not equal to int max, which means it is possible, I'll return result. Fine. So now come to this problem. You will learn why I returned 90 max here. Come to include one part, like solve of I. I'm staying at I index only. Coins is the array. I'm deducting coins of I every time. When it calls itself, if amount is less than equal to 0, I'm minusing it. Fine. For example, take it 1, then again it will be minusing 1. Like here only. Like it was 11. Fine. It was 11. So it will be like 11 minus 1, which will be 10, then 10 minus 1, which will be 9, and so on, and it will take 11 coins. Fine. Now, the recursion will go to the next point. Fine. It will be returning 11. Fine. So, I have used this because every time it will be sending the call, it will call out if it is not equal to int max, then I'll be incrementing the number of coins as well. Okay, remember it. The number of calls, there must be a incrementation in the include part. Fine. Then you will learn about the exclude. Just we are skipping the coin and we are going to the next coin. And these two recursive call will help us make it. Fine. I returned 0 here because we are using the minimum. Fine. And anti-max and return 0. What will be the minimum part? It will be always be 0. So in this question, you will see that I have used a single dimension DP. I'll give you a reason why. That the only thing that was changing here was n. There was no another thing that was changing here. So I could use a single dimension DP. But when you come to this question, there are two things which are changing. One is index and second is amount. So we need a 2D DP. Fine. So I'll be creating it. Vector of vector int TP. Uh, it is memoizing, so it will be coins. Like it is I. So what is the here constraint that coins of size -1 greater than? Fine. Dot size. Fine. The very first thing will be here. And now resizing the inner vector. And this will be giving amount plus of 1, comma -1 to avoid the overflow. Now I'll send DP into this function call. Now again, vector of vector. This takes a lot and lot of time too. So I'll be using this way. I'll be copying it from here. I'll be pasting it here. And yeah, and here. Yeah. If dp of I and amount not equal to -1, return. This is a very similar concept I have used in the last video. You can check my last video again. That will help you to come up with simple concept of dp. Fine. And it will be returned dp of I and amount equal to minimum of include and exclude. Now just give it a function called properly so that it doesn't give an error again, which will be a compile time error, and I'm very sure that it will be again there. Sorry, it is not. Fine. So this is a way that you can escape from the delusion that DP is very tough. Create a recursive function. Check for the things which are changing into it. Fine, like here it was index and amount. Make a DP of it, make a vector accordingly, and use it. That's what DP is. Hope you like this video and might this video have helped you understand it. If you want something else like notes over it, I can provide that as well. You can comment for it. And that's it. Thanks a lot for watching this video and have a nice day.